Welcome to The Explainer. Today, we're diving deep into what it really takes to build a state-of-the-art AI from scratch. And we're going to use the recently released Olmo 3 as our guide to see how it's done.
So let's start with the big question, right? How do you actually build one of these things? This isn't just a thought experiment, it's a massive challenge that some of the world's top researchers are tackling, and it takes an incredible amount of data, power, and, well, clever thinking. So where do you even start?
Well, it all starts right here, with the data, piles and piles of it. You can think of it as the primordial soup that all modern AI crawls out of. Before an AI can learn to reason or write or code, you first have to decide what it's going to read.
So here's our game plan. We're going to walk through the entire process step by step from those raw ingredients all the way to a finished powerful AI. Let's get into it.
First things first, let's meet the star of our show. What exactly is Olmo 3?
So Olmo 3 isn't just one single AI. It's more like a whole family of them, built by a huge team over at the Allen Institute for AI. You've got the foundational base model, a conversational instruct version, a specialized think model for heavy-duty reasoning, and even these RL0 models. That RL0 part is pretty cool. It's basically where you teach the AI by giving it a gold star for good answers. But the big idea behind this whole project was a serious commitment to being transparent.
Okay, now let's get to what might be the most critical stage of all, putting together the data. You know, you can't bake a world-class cake with junk ingredients, and it's the exact same story with AI.
Get this, the team started with a pool of over 9 trillion tokens. A token is basically a word, or sometimes just part of a word. This massive collection, called Dolma 3, is the raw clay they're going to use to sculpt the final model. It's just an almost unimaginable amount of text and code. Now, they didn't just dump all 9 trillion tokens into the machine. No, instead, they very carefully put together a special 6 trillion token diet for the AI. And the secret sauce here is the mix. Sure, general web stuff from Common Crawl is the biggest chunk, but look at how they strategically loaded it up with scientific papers, code, and math. This wasn't just about more data, it was about feeding it the right data to build a super strong foundation in complex thinking.
So, how'd they figure out that perfect recipe? This is where it gets really clever. They used something called a swarm-based approach. Instead of just guessing, they trained dozens of tiny, cheap-to-run models, each one on a different data diet. Then they basically had them compete against each other to see which data mix created the smartest mini-model. It was like a tournament to find the winning recipe before they committed to the gigantic final training run.
And you know what they found out? It was a game changer. By strategically choosing their data and seriously boosting the amount of high-quality science, math, and tech content, they could build a way smarter model than if they just used the data as they found it. It proves that it's all about quality and composition, not just sheer quantity.
All right, the ingredients are mixed, the recipe is set, now it's time for the main event, pre-training. This is the first bake, the most power-hungry part of the whole process, where the model actually learns the fundamental patterns of language and knowledge from that massive dataset. What you're looking at here is basically the model's first report card. It's called a loss curve. That vertical line, the y-axis, shows loss, which is just a fancy word for its error rate. As the model chews through trillions of tokens, you see that line go steadily down, down, down. That's the proof right there. It's visual confirmation that, hey, this thing is actually learning.
And this is where the sheer scale of all this really hits you. Just this one phase, training the base model on those 6 trillion tokens, ate up more than 90% of the total computing power for the entire Olmo 3 project. We are talking about hundreds of super powerful NVIDIA H100 GPUs running nonstop for weeks. It's just wild.
So, pre-training gives the model its foundational knowledge. Let's call that its bachelor's degree. But to really become an expert, you gotta send it to grad school. That's what the team calls mid-training, where they give it a PhD in specialized stuff, like advanced math and coding. But while the model was in grad school, the team ran into a really big problem, one that actually plagues a ton of AI development. It's called benchmark contamination. Basically, it's when the answers to the final exam accidentally get mixed into the study materials, which lets the model cheat by just memorizing answers instead of actually learning how to solve the problems.
So they went through their data with a fine-tooth comb and, yep, they found thousands of these little cheat sheets. For some of the tests, like one called Drop, the score was obviously inflated. When they took the cheat sheets out, the score plummeted, which is exactly what you'd expect to happen. But then they noticed something really weird.
And this is the wild part. For the grade school math test, called GSMAK, the model's score actually went up after they removed the contaminated answers. The theory is that by taking away the easy memorized answers, they forced the model to learn the real reasoning behind the math, which made it better at solving new problems. It turns out, sometimes making the test harder actually makes the student smarter. Who knew?
Okay, we're in the home stretch. The model is smart, but now we have to teach it how to be a useful assistant. This happens through a process called reinforcement learning, where you reward the AI for good, helpful answers. And the Olmo 3 team found a way to make this whole thing way more efficient. A big part of that was an upgrade they call continuous batching. The old way, static batching, is kind of like waiting for the slowest person in your group project to finish before anyone can move on. If one part finishes early, the computer just sits there doing nothing, wasting time and energy. But continuous batching is way smarter. The second a task is done, a new one gets fed right into the pipeline. No more idle GPUs.
And the difference was just massive. This one change saved a staggering amount of computing power. We're talking up to 54% of the compute time that would have just been gone, wasted. This made the whole final phase faster, cheaper, and way more efficient.
Okay, so after all of that incredible work, the data, the training, the mid-training, the fine-tuning, what's the big takeaway here? Why does a project like Olmo 3 really matter to all of us?
Because here's the thing. The team's true contribution isn't just the AI itself. It's their radical, hardcore commitment to being open. They didn't just give us the final product. They gave us the entire blueprint, the full data recipe, the training code, even their evaluation tools. It's all out there for anyone to use. This means people can see exactly how the sausage was made, and more importantly, they can learn from it, replicate it, and build the next great thing on top of it.
And that level of transparency, it does more than just help a few researchers in a lab. It democratizes the whole field. By sharing the entire playbook, the Olmo 3 team changed the conversation from just what they built to how they built it. They've handed the tools to builders and innovators everywhere, and that leaves all of us with a really big, fascinating question for the future.